Domain and range, no it's not the same. Rational functions, I'ma teach you ain't nothing. Palomo always give us something hard, then he loud when we fail. Now he turn the dealer guard, found the HA, the VA, and the little hole. HA is Bessie, but TD and Bobo for the whole. Cancel out and start plug it in for the vets at the bottom of zero and start grabbing. I'm a little breezy doing math, now you queasy with this problem like in Fiji. Having what thoughts like Riri domain, lift the right range, bottom to top, like -1 to 99. Big bird, have you heard? I got the words, finna go down like it's the purge. Feeling like the done, cause now I'm mad. Look at you looking all sad. Find the Dior, find the Dior, find the Dior, we find the Dior, find the Dior, find the Dior.
Today you will be learning how to find the domain and range for rational functions. Rational functions are functions that are in fraction form. As you watch this, you will learn the way to find the domain and range for them, and you'll never forget. Now let's get to the video.
Today y'all go learn about domain and range. Y'all should be able to learn it quick because this is fast track, algebra 2. We're doing math today. The first problem is x plus 4 over x squared plus 5x. First thing you're trying to find is the HA, which is the horizontal asymptote. To find this, you use an acronym called Betsy, Bobo, and BoTD. Betsy means bottom equals top, so you use the coefficient. Bottom, bigger on bottom, so 0, and bigger on top, so it's undefined. So first thing, we got to look at these, the exponents, and it's bigger on bottom, so that means that the horizontal asymptote is 0. So we're gonna draw the little dotted line thingy. Then you're trying to find the whole. Finding whole, you'll have to factor out the problem. And whatever cancel out, you set it equal to 0, and that's your x value. So that means that's going to be -4. And then you plug it in, so it's a 1 on top, and that's -4 plus 1, which is 1 over -3. So the y value is -1/3. Next, you're trying to find a vertical asymptote, and you set the bottom equal to 0, which haven't been canceled out, which is x plus 1, so that's -1. So the vertical asymptote is right here. And the whole is -4. And -1/3. So we're gonna draw it. So the domain is left to right. So you got negative infinity to the whole, which is -4, union -4 to the vertical asymptote, which is -1, union -1 to infinity. For the range, it's negative infinity to the whole, which is -1/3, union -1/3 to the horizontal asymptote, which is 0, and union 0 to infinity. Stop it. That's the first one. This is question number 2. First thing we're going to do is see the horizontal asymptote. So they're both equal, so that means it's the coefficient, which is 1. So the horizontal asymptote is at 1. So So do the little dot. And then next we need to factor this out. So you're gonna have x minus 4 over x minus 2 and x minus 4 and x plus 3. So we're gonna do the whole next. The negative 4's cancel out. So it's gonna set it equal to 0 and get 4. And then you get 4 minus 2 and 4 plus 3, which is equal to 2 over 7. So that's the y value, 2 over 7. Vertical asymptote, equal this out to 0, and that's going to be negative 3. So the vertical asymptote is 1, 2, 3, negative. And the whole is 4. 1, 2, 3, 4. And 2 sevenths. So it's like right there. And then when you draw this, it's like that. And this is like that. So the domain will be negative infinity to the vertical asymptote at negative 3 union negative 3 to the whole at 4 union 4 to infinity and beyond. Next one for the range is negative infinity to the whole, which comes first, is 2 sevenths union 2 sevenths to the horizontal asymptote, which is 1 union 1 to infinity. Okay. Example number 3. So first thing we got to find is the horizontal asymptote. So is these are equal. So it's gonna be the first one. Do the coefficient, which is 2 over 1. So the horizontal asymptote is at 2, 1, 2. The whole, got to factor this out. So on the top, it got a GCF of 2. So you bring out the 2 and do x squared minus 6x plus 8. And then the bottom is the same, x squared minus x minus 12. Now we go factor these out. So 2, then x minus 4 and x minus 2. And then on the bottom, x minus 4 and x plus 3. Now these two cancel out. So there's a positive 4 for the x value. And we go plug it in. Make sure you keep that 2. So 4 plus 3 and 4 minus 2. So 2, that's 4 over 7. So that's 4 over 7. And then equal this out to 0. X plus 3 equals 0. So that's going to be negative 3. So the vertical asymptote is at negative 3. And then the whole is 4 and 4 sevenths. So right there. And you go draw it. Like that. And then do the domain, left to right, negative infinity into the vertical asymptote at negative 3, union negative 3 to the whole, which is 4, union 4 to infinity. And for the range, negative infinity to the whole, because it comes first, which is 4/7. Union 4/7 to the horizontal asymptote 2. Union 2 to infinity.
You just learned how to find your domain and range for a rational function. First, find the horizontal asymptotes, the whole, and the vertical asymptotes. Then graph the information that you get, find the domain and range. Remember, domain is from left to right and range is from bottom to top.
Fast track, algebra 2.